Hello students, welcome to AIMS India online classes. This is a chemistry session. Here we are discussing about the chapter Is Matter Pure? In this session, we are going to say about concentration of a solution and different expressions used for finding the concentration of a solution. The concentration of a solution is the amount of solute present in a given quantity of the solution. In other words, the mass of the solute in grams which is present in 100 grams of a solution. Okay, actually the concentration of a solution can be expressed in different terms. One of the definitions is the concentration of the solution is the amount of solute present in a given quantity of the solution. So how much solute is present in the given quantity of the solution is its concentration. Actually, the concentration represents the quantity of the solute present in the solution, either in the solution or in the particular quantity of solvent. To say simply, the mass of the solute in grams which is present in 100 grams of a solution. It is represented as the concentration. In a solution, the relative proportion of the solute and a solvent can be varied. Yes, in a solution, we cannot say always the quantities or proportions of the solute and solvent are fixed. We cannot say like that because these are not pure substances. These are mixed substances in which components may vary their composition. So even in the solutions also, the proportions of the solute and solvent may be varied, can be changed, can be varied. If you see, suppose a solution is prepared from water and a solute here. So these all of the solutions of the same substance, same solute. But the quantity of the or the proportion of the solute is changed from one test tube to other test tube. So these all are the same kind of solution, but the proportions of the solute and solvent are varied in these all. That's why you can see clearly the darkness or the color shade difference. As the quantity of the solute increasing, the color of the solution became dark. But in all the solutions, the solute and solvent both are same. But what is the difference? Their proportions are being varied. Not only in this, in almost all the solutions, the proportions of the solute and solvent may be varied. They can be changed. So, in a particular solution, the quantity of the solute present in a particular or unit quantity of solution is expressed as the concentration of the solution. Okay, depending upon the amount of solute present in a solution, it can be called a dilute solution, concentrated solution, or a saturated solution also. So based upon the amount of solute present in the solution, it is named in different terms like dilute solution. What does it mean, dilute solution? The solution in which the quantity of solute is very less when compared to the quantity of solvent. The quantity of solvent is more than that of the quantity of solute, much, then the solution is said to be dilute solution. And next, some solutions are called concentrated solutions. What does it mean, concentrated solution? The solution in which the quantity of solute is much more than that of the solvent. Then that solution is said to be concentrated solution. Okay, some solutions are called saturated solutions. What are they called? So, which solutions are called saturated solutions? The solutions in which they have required amount of solute in the dissolved in the solution. The solution, in simple way, the solution which cannot dissolve any more solute into it, as it has the required amount of solute dissolved already. Such kind of solutions are called saturated solutions. So these all definitions are different terms are given for the solutions based upon the quantity of the solute present in the solution. Okay, different substances in a given solvent have different solubilities at the same temperatures. Yes, all the substances may not be dissolved in the some solute at the same quantity. Suppose if you take different substances, solid substances like sugar, salt, some urea, some glucose, if you take these all, if you try to dissolve these different solid substances into same quantity of water in different containers, all the substances won't be dissolved in the same quantity. One might be dissolved in more quantity to form saturated solution, but some other they may dissolve very less quantity only. So we can say the solubility of different solutes will be varied from one to another in a particular solvent. Okay, the different substances in a given solvent have different solubilities. One may have more, one may have less at the given temperature. The most common method for expressing the concentration of a solution is called percentage method. Yes, actually, to express or to know the concentration of a solution, we use a different terminology or different methods like percentage method, molarity, normality, mole fraction. These all are the different expressions or methods which are used to find the concentration of a solution or which are used to express the concentration of a solution. But out of these all, the most common one is a percentage method. The remaining we are going to learn in the higher classes. Now let us see about this percentage method of expressing concentration of a solution. The concentration of a solution refers to the percentage of solute present in the solution. Yes, actually this percentage solution represents the percentage of the solute present in the solution. The percentage of solute can be expressed in different terms. Yes, actually here the percentage of solute present in the solution can be expressed in different terminology. Let us see what are those different terms used for expressing the percentage of solute. One of them is a mass percentage. The weight of solute in grams present in 100 grams of solution is called mass percentage. What is that? The mass of solute or the weight of solute present in 100 grams of solution. So if we find the solute weight in grams, that is said to be mass percentage. If the solution is of a solid solute dissolved in a liquid, then we consider the mass percentage of solute in calculating the concentration of the solution. Yes, actually, generally this expression, that is mass percentage, is used for calculating the concentration of certain solutions in which the solute is solid substance. Then we use this expression method, mass percentage, because we are defining this as the mass of the solute present in 100 grams of a solution. So to generally for solid substances we take mass easily. That is why this mass percentage expression is used to calculate the concentration of the solid liquid solutions or in which the solute is a solid. So, in the case of solid solute dissolved in a liquid solvent, the mass percentage can be expressed by using the formula mass percentage of a solution is equal to mass of the solute by mass of solution taken in grams into 100. This gives the mass percentage of the solution. That means it gives the mass or weight of solute in grams present in each 100 grams of solution. Nothing but the mass percentage or mass by mass percentage. Okay, this is one of the types of expression used for calculating the concentration of the solution. Generally, it is used for the solutions in which the solute is a solid substance. Okay, here in the denominator, we have written mass of the solution. Here, mass of the solution, sometimes they may not give in the solid examples. So what they may give? They may give weight of solute and weight of solvent. If these two are given, we can find out mass of this solution by using the formula mass of solution is equal to mass of solute plus mass of solvent. The sum of these two gives the mass of solution. It can be substituted in that. Okay. Now let us see some solved example based upon this expression mass percentage to calculate the concentration of a solution. See the question given. If 10 grams of sodium hydroxide is dissolved in 190 grams of water to form a solution, then calculate the concentration in terms of mass by mass percentage of the solution. Okay, they're asking to calculate concentration in terms of mass by mass percentage. What they have given data? They have given 10 grams of sodium hydroxide is dissolved in 190 grams of water to form a solution. So if you're able to understand the data given, then we can find out easily the mass by mass percentage of the solution. Okay, let us try to solve this. First, see mass of the solute, that is mass of sodium hydroxide. Why sodium hydroxide is solute here? If you observe the quantities of the two substances given, mass of sodium hydroxide is lower, smaller. So the component in the solution which is in smaller quantity is taken as solute, and this is a solvent. So here in this solution, sodium hydroxide is solute, water is solvent. Okay, now mass of solid, how much they have given? It is given as 10 grams. Now let us try write mass of solvent given, that is water. What is the amount of water given? 190 grams. So mass of solute is given, mass of solvent is also given. To find the mass by mass percentage of a solution, what is the formula? Mass of solute by mass of solution into 100. But here they did not give the mass of the solution, but we can find it out. How? The sum of the mass of solute and mass of solvent gives mass of the solution. So mass of solution is equal to solute mass plus solvent mass. Total it becomes 100, 200. So mass of solution also we found here. Now let us see the formula to be used to calculate mass by mass percentage of the solution. What is that? Mass by mass percentage is equal to mass of solute by mass of solution into 100. So let us substitute all the values in this. Okay, mass of solute is 10 grams. Mass of solution is 200 grams into 100. This gives 5%. So the mass by mass percentage of the solution is 5%. That means in every 100 grams of solution, there will be 5 grams of sodium hydroxide. That is the meaning of this 5%. Okay, this is mass by mass percentage, which represents the quantity of solute in grams present in every 100 grams of the solution. As we have got it here as 5%. This represents there will be 5 grams of sodium hydroxide in every 100 grams of solution when we dissolve 10 grams of sodium hydroxide into 190 grams of water to form a solution. Okay, in this way we can calculate mass by mass percentage. Next, let us see volume percentage. It is one more expression to calculate concentration of a solution. It is defined as the volume of solute present in 100 ml of solution. The volume of solute present in 100 ml of solution is called volume percentage. Just in terms of mass, it is expressed in terms of here volume. Volume of solute present in 100 ml of solution. So here both are expressed in ml, milliliters. So the formula to calculate volume percentage is volume by volume percentage is equal to volume of solute by volume of solution into 100. Here one point we have to remember is whenever you write a formula like this, or if you substitute the values of this volume of the solute, volume of the solution is all Remember that these all should be the same units. If you take this in the milliliters, this also should be in the milliliters. If you take this volume of solute in liters, then volume of solution also should be taken in the liters. That means both should be in the same units, same system of units. Okay. Next, let us see one solved example based upon this volume by volume percentage also. Okay, see the question. Determine the volume by volume percentage of a solution made by combining 25 ml of ethanol with enough water to produce 200 ml of the solution. See the quantities given, what are the data given in this, so that we can find out the volume by volume percentage. So let us see solution for this. First, they have given 25 ml of ethanol and it is formed 200 ml of solution. Okay. See, volume of solute, that is volume of ethanol, is given as 25 ml. Next, volume of solution they have given 200 ml. Don't be confused here. They have given directly the volume of solution formed finally. They did not give here volume of the solvent. Directly they mentioned here volume of solution. Now, need not to add these two again. Directly solution volume is given, no. Okay. Now, the formula to calculate volume percentage is volume of the solute by volume of solution into 100. Let us substitute these values now. See, volume of solid is 25, volume of solution is 200 into 100. Remember, and these two are the same system of units. Okay. Now we can calculate this. We get it as 12.5 percentage. That means in every 100 ml of the solution, there will be 12.5 ml of solute or ethanol. Okay, in this way, we can find out volume by volume percentage of a solution. It is one kind of expression where generally the solute and solvent both are liquids. Okay, next one more expression, that is mass by volume percentage. It can be defined as the weight of solute present in 100 ml of solution is called mass by volume percentage. Generally, this expression used when the solute is solid substance and the solvent is liquid substance and finally they form a solution. Then this mass by volume percentage expression is used to calculate concentration of the solution. Okay, the formula to calculate mass by volume percentage is mass of the solute in grams by volume of solution in ml into 100. Depending upon the unit of the mass and volume, the mass by volume percentage of a solute in solution can have units grams per ml or grams per liter. Yes, the units may be varied when the units of the solution or quantity of the mass varied. Okay, now let us see one solved example based upon this expression also, mass by volume percentage. See the question given, if 100 grams of hydrochloric acid is dissolved in water to produce 1 liter saturated solution, then calculate the mass by volume percentage of the solution. What they have done here, 100 grams of hydrochloric acid is dissolved in 1 liter dissolved in water to produce 1 liter saturated solution. So what they given here, weight of solute is given and the volume of solution is given. They did not mention what is the volume of water here. They mentioned the volume of the solution formed after mixing this HCl. So directly volume of the solution is given and they're asking to find out mass by volume percentage. So let us write the data first. Mass of solute, that is mass of hydrochloric acid, is HCl mass, what they have given, 100 grams. And next, volume of the solution, they mentioned it as 1 liter. And mass by volume percentage formula, we have it as mass of solute by mass of solution into 100. If we substitute these values, mass of solute is 100 grams, mass of the solution, actually here, as we told, these all should be the same system of units. Actually, we have taken mass of solute in grams, but the volume of the solution is given in liters. So this volume of the solution also should be converted into CJ system, that is 1000 ml we get. So if we substitute these values, we get it as 10 percentage. Okay, that means there will be 10 grams of hydrochloric acid in every 1000 ml of solution. Okay, in every 100 ml of solution. So mass by volume, yes, there will be 10 grams of hydrochloric acid in every 100 ml of solution. That is meaning here 10 percentage. Okay, in this way, concentration of the solution can be expressed in different forms. What we have seen now, one of them is mass by mass percentage. Generally, the solutions in which a solute is mass, a solid substance, they use this formula mass by mass percentage. The second one is volume percentage or volume by volume percentage. This is generally used or expressed for finding the concentration of the solutions in which both solute and solvent are liquids. And third one we have seen mass by volume percentage. Okay, this generally can be used for where the mass of the solute is given and the volume of solute is expressed. Solution is expressed. Okay, these are different terms of concentrations. Thank you for watching our video. Please subscribe our YouTube channel Aims Today for latest updates on recorded videos.